Siemens acquires Altair to create a most complete AI-powered portfolio of industrial software. Siemens announced today that it has completed the acquisition of the Altair Engineering Corporation, a leading provider of software industrial simulation and analysis market for enterprise values of approximately USD $10 billion. With this acquisition, Siemens extends its leadership in simulation industry artificial intelligence by adding new capability in mechanical and electromagnetic simulation and high-performance computing, HPC, and data science and AI. The addition of the Altair team technology and Siemens will further enhance the most comprehensive digital twin and make simulation more accessible, so the companies of any size can bring complex products to the market faster. We welcome the entire Altair community of the customer, partners, and colleagues to Siemens. Adding Altair groundbreaking innovations, Siemens Accelerator platform will create the world's most complete AI-powered design, engineering, and simulation portfolio. Together, we will help our customers to innovate at scale at the speed of today's complexity-driven world demands, said Noel Bush, President and CEO of the Siemens AG. Through the One Touch the Companies program, we will extend our leadership in industrial software. This enables all industries to benefit from the revolution driven by data and AI. Integrating the Altair's capabilities in the areas of the simulation, HPC, data science, and AI enhances the ability of Siemens to drive more efficient and sustainable projects and processes. Now, all Siemens customers, from engineers to generalists, will have access to new simulation expertise, can optimize their high-performance computing processes, creating a new AI tools and perform data analytics to help accelerate innovation and digital transformation for companies of all sizes. The execution of Altair is part of Siemens One Tech company program and will meaningfully increase the Siemens digital revenue share. This growth program enables Siemens to further extend its strong market position and reach the next level of performance and value creation. Through the acquisitions like this, as well as R&D investment into areas including software, AI-enabled product and connected hardware and sustainability, Siemens is clearly prioritizing the capital allocation to the strategic growth field. With the completion of the acquisition of Altair as well as the recent expansion, Siemens factories in California and Texas, Siemens has now invested over USD $100 billion into the United States in the past 20 years. Qualcomm initiated global antitrust complaint about the ARM. The Qualcomm has initiated anti-competitive complaint against the ARM in the US, Korea, and Europe, reported Bloomberg. Qualcomm is alleging that after 35 years of running an open licensing operation which is open to all and in which all its licensees are treated equally, the ARM is now restricting the access to its technology in order to make chips in competition with its licensees. Qualcomm argues that ARM business model which important competition in the chip industry and created a widespread reliance the ARM technology is in process being transformed into an anti-competitive model favoring ARM. Qualcomm has made the complaint to US FTC, the EC and the Korea Fair Trade Commission. At the recent ARM versus Qualcomm trial, the Qualcomm's lawyers produced a strategic comment written by ARM's CEO Rene Haas and represented to the ARM board, which envisaged ARM building its own chips. When asked about the document in court, Haas replied ARM didn't build chips but always had to look to the future. The ARM reported either looking at selling its own proprietary chips and it alleged that one of its first customers could be Meta. Like many of the hyperscalers, Meta is looking at its own AI chips to avoid the high-priced NVIDIA chips. NVIDIA to spend hundreds of billions on US-made chips, comes up with Blackwell Systems production in the US. Jensen Huang, chief executive of NVIDIA, confirmed at GTC 2025 that the company plans to spend hundreds of billions of dollars on chips made in the US over the next 4 years, reported the Financial Times. The decision comes as the company works to lessen its reliance on Asian manufacturing due to the potential tariffs under the Trump administration and geopolitical instability surrounding Taiwan. The company is also producing Blackwell systems in the US. NVIDIA to spend hundreds of billions on American chips. We are in it, Huang said at the GTC press conference, answering a question about the production and TSMC Arizona, report to Reuters. We are now running production silicon in Arizona. Huang also confirmed to the Financial Times Blackwell systems are being produced in the US. Huang did not elaborate on which chips are being manufactured at TSMC's Fab 21 in Arizona, nor did he disclose volumes that NVIDIA is producing there. The phrase running production silicon means that the actual chips, not test or prototype chips, are being manufactured. It does not necessarily imply high volume production, but while the volumes of the NVIDIA's chips made in the US remain unclear, NVIDIA is set to increase manufacturing in America over the course of the next 4 years. Overall, we will procure over the course of the next 4 years probably $500 billion worth of electronics in general, total, Jensen Huang told the Financial Times, and I think that we can easily see ourselves manufacturing several hundred billion of it here in the US. It should be noted that while unit sales of discrete GPUs for client PCs are generally decreasing, the die sizes of flagship graphic processors are increasing. So the silicon real estate that NVIDIA produces is also expanding. Additionally, sales of the NVIDIA's gigantic data center GPUs are on the rise, and the company expects this to continue for the next several years. Therefore, it is not surprising the company plans to spend roughly $500 billion on chips in the next 4 years. NVIDIA is mostly known for its GPUs for client PCs and data center. In addition to GPUs, NVIDIA also designed its own CPUs, GPUs, NVLink switches, networking chips, and system-on chips for vehicles as well as various embedded applications. The vast majority of the NVIDIA silicon is produced by TSMC. Most chips are made by other foundries. However, NVIDIA's products and NVIDIA-based products are also use numerous other chips not designed by NVIDIA or produced by TSMC. For example, the company uses CPUs developed by AMD and Intel, as well as GDDR and HBM memory made by Micron, Samsung, and SK Hynix. It also uses a variety of the components from other suppliers, including retimers, system management controllers, clock generators, power management CSs, ICs, analog devices, and various controller microcontrollers, to name a few. Companies produce memory, Micron, SK Hynix, and other components, analog devices, GlobalFoundries, and Texas Instruments are all building new production capacity in the US. Micron Fab is coming online in 2027. SK Hynix is expected to follow in 2028. And TSMC Fab is expected to be operational in 2025. As a result, NVIDIA may increasingly source these components from American facilities. Furthermore, NVIDIA next generation x86 servers will use AMD's and Intel CPUs, and that could be produced by either TSMC in Arizona or Intel in Arizona. That said, that an expanded production of semiconductor in the US, it would not be surprising if the NVIDIA spends several $100 billion on silicon made in America in the coming years. However, a key question is whether the hundreds of billions Jason Huang meant close to $125 billion or between $250 billion and $300 billion. As many new fabs in the US are coming online in the latter half of the decade. One subsystems. For Q and financial year 24 financial result. Revenue up to 15% of the Q over Q and up 10% year over year. Company expect to double digit revenue growth in financial year 25. Strength in both segments contribute to consolidated year-over-year revenue growth for Q4 2024. Consolidated revenue increasing sequentially every quarter throughout the year 2024, reflecting the success of the company's transformation strategy to higher growth markets. Management expects double-digit consolidated revenue growth in 2025, 3.9 anticipated OSS segment revenue of over 20% and consolidated EBITDA break even for the years. One-stop systems incorporation. Reported results for 3 and 12 periods ended December 31st, 2024. Comparison for the 3 and 12 months period are the same year ago period unless otherwise noted. I'm pleased to report a return to consolidate year-over-year revenue growth for the fourth quarter as sales from both our OSS and Bressner segment grew at the double-digit rate. Throughout 2024, we executed on our multi-year transformation, making significant progress in shifting business toward a higher margin, higher growth market, and we invested in our platform. Strengthened our pipeline and depended on collaboration with the customer developing high-performance enterprise-class and edge computing solution for both commercial and defense applications, stated Mike Norris, President and CEO, OSS. As effort to reposition the company for revenue growth gained momentum during 2024, and our business model developed. We adjust our legacy inventory and the program cost to better align with the focus on improving efficiencies and increasing profitability. We believe the progress we made in 2024 strengthens our business and positioning the company for higher sales and profitability in 2025 and beyond. Concluded Mr. Norris. And 2024 fourth quarter financial summary. Consolidated revenue was $15.1 million compared to $13.2 billion in the fourth quarter of 2023. The 15.1% year-over-year increase was the result of a $1.3 billion increase in Bressner segment revenue and $642,000 or year-over-year increase in the OSS segment revenue. The 10% year-over-year increase in OSS segment revenue was primarily due to the higher revenue from the defense and commercial customers, as well as the customers funded and developed other aligned directly the company's strategic focus and plans. The following table set forth the revenue by segment for the 3 months ended December 31st, 2024 and December 31st, 2023. Dollars may not calculate due to the rounding. And I need to do another article. The Synopsys autonomous AI agent attained the chip design complexity. At the annual Synopsys SNUG conference here in Santa Clara, California, and the company CEO Satsun Kaji and the spell out the path to using the AI agent to increase the complexity of chip design. In his keynote speech on the Wednesday at the opening of the 35th year of the SNUG conference, Kaji talked about the path analog to the automotive industry transition from advanced drivers ADAS to the fully autonomy. With an agentic AI development framework that visions progress from the foundation of AI capability to fully autonomous multiple agent systems capable of high decision making and actions. He emphasized the need to engineering the level of pervasive intelligence and how this meant it was a special time to be an engineer to create innovation required for AI. Highlighting the NVIDIA's Jensen Huang's comment that he would lead to million Synopsys engineers to address design complexity. Gage implied this could be addressed with AI agents working in a partnership with the human engineers. The challenge is Gage said that complexity is impacting every industry, and hence the engineering teams face exponential challenge in the delivering future product. So agent and ultimately autonomous collaborative AI agent will be the answer. This was reinforced during his fireside chat with CEO, the ARM CEO Les Haas later in the day, when they talk about getting from the ideation to tape out the less and less time, especially with the expectation of a typical design cycles needing to get a shorter while chips get even more complex. The expectation of the faster product development cycles will accelerate further. As NVIDIA's Huang also talked to the day before this keynote about the yearly cadence of new product introduction. Not just new generative AI-powered assistive and creative capabilities unlocking the additional levels of the efficiency for customers, improving their design and accelerating their time to market. Again, Gage said, still when it comes to AI-driven EDA, we are just scratching the surface of what's possible. We see future paradigm-shifting opportunity to agentic AI, which will allow R&D teams to focus on important architecture and design decisions while tasking the agentic engineers with implementation details. And you can watch the E-Times video interview with him in the event below. We also spoke to Synopsys Chief Product Development Officer Shankar Krishnamurti to dive into some of the details of this and other announcements to both from Synopsys and also with its collaboration with NVIDIA. You can watch this video interview below. Agent engineers taking to human engineers. With a portfolio of AI software-defined systems that Silicon and the worldwide world of the Silicon design and system design covering, which is what we have been told by the companies like Synopsys over the last couple of years. Gage said in his keynote, the engineers are facing the truly exponential challenges to deliver these future projects. In order to address this, they highlighted the 6 key technological factors that will be key to delivering the advanced intelligent system solutions. Advanced packaging with 3D ICs is playing a crucial part. Advanced IP nodes and the verification, and Silicon's lifecycle management, especially with on-chip health monitoring that becomes more even insecure with the 3D ICs, advanced CDA. In order to tame the complexity, the advanced silicon for AI, he said he is aware both assistive generative AI and eventually creative generative AI will help the workflow significantly. Agent engineers will collaborate with the human engineer, he said. The Synopsys accelerated chip design with NVIDIA, Grace, Blackwell, and the AI to speed the electronic system design automation. Announcing up to 30 times projected performance gains on the NVIDIA's Grace Blackwell platform to speed circuit simulation for next generation semiconductors. Sunnyvale, California, March 18, 2025. Synopsys Corporation today announced that the next phase of its work with NVIDIA to accelerate chip design up to 30 times with the NVIDIA Grace Blackwell platforms. To achieve the speed up, the Synopsys announced at the GTC Global AI Conference using the NVIDIA CUDA X libraries to optimize each solution for next generation semiconductor developed. The company is also expanding the support for NVIDIA Grace GPU architecture and enabling the more than 15 Synopsys solutions in 2025. At GTC, we are unveiling the latest performance results observed across the leading portfolio and optimizing the Synopsys solutions for NVIDIA Blackwell platform to accelerate the computational intensive design workflows, said Cécile Gezi, the president and CEO of Synopsys. The Synopsys technology is mission critical to productivity and the capabilities of the engineers teams from silicon to systems. By harnessing the performance of the NVIDIA accelerated computing, we can help the customers unlock the new breakthroughs and deliver innovation even faster. Chip design is one of the most complex, signing the challenges in the human history, and said Jensen Huang, founder and CEO of the NVIDIA. With the NVIDIA Blackwell CUDA X, Synopsys is cutting the simulation 5 times from days to hours and advancing the chip designs to power to the AI revolution. The Synopsys NVIDIA are advancing a multi-year collaborative effort to accelerate the design, electronic design automation EDA workloads. Synopsys is further applying the NVIDIA accelerated the computing architecture, including the NVIDIA GB200 Grace Blackwell superchip, to achieve significant projected runtime gain for the workflow, including circuit simulation, computational lithography and technology computer aided design, TCAD, physical verification, and materials engineering. So these accelerated workflow include circuit simulation, Synopsys Prime SPICE simulation workloads are projected to achieve 300 at 30 times speed up to utilizing the NVIDIA Grace Blackwell platform. Today, the customers can achieve 115 times speed up utilizing the NVIDIA GH200 superchip. So the NVIDIA accelerated computing architecture enables the simulation of challenging the circuit to achieve the sign-off of the SPICE new level accuracy, reducing runtimes from days to hours. Computational lithography. The production proven the choice for accelerating computational lithography for more than the decade. Synopsys Proteus provided optical proximity correction (OPC) software and inverse imaging technology (ILT) to resolve challenges and leading technology nodes. By leveraging NVIDIA technologies, Synopsys is delivering a game-changing technology to advance to this computationally intensive manufacturing process. So today, the Synopsys Proteus is optimized the NVIDIA 110 H100 GPUs and integrated with the NVIDIA QLitho library, achieving a 15 times speed above OPC. Leveraging the NVIDIA Blackwell platforms, Synopsys Proteus is executed to accelerate the computational lithography simulation by up to 20%. 20 times. The TCAD simulation, early results applying the GPU, enables the capabilities of NVIDIA's CUDA library. semiconductor material research developed utilizing CUDA 10 libraries on the NVIDIA Hopper architecture can accelerate with times to the result up to 100 times, enabling customers to simulate and analyze a wide range of the material with the greater efficiency. So Synopsys plans to continue to enabling accelerated computing on NVIDIA's performance platforms throughout its portfolio of Synopsys solution with NVIDIA AI software. Synopsys and NVIDIA effort to accelerate chip design to extend speeding up the design with the generative using the NVIDIA's NIM microservices. The AI is a generative AI software for chip design. Today's customers using the Synopsys Gen AI powered knowledge assistance. Synopsys.ai Copilot are realizing an average 2 times productivity improvement compared to a prior method. The integration of the NVIDIA NIM microservices projected to enable an additional 2 times speed up for even faster time to answered. Optimizing Synopsys EDA to Grace CPU. Additionally, Synopsys is enabling more than 15 solutions in the Grace CPU architecture for Synopsys EDA workloads spanning the circuit simulation, physical verification, and static time analysis, and the functional verification. The company plans to further increase support on the Grace CPU architecture in 2025. Synopsys said GTC 2025. Synopsys demonstrated in GTC 2020 March 18th through 21st in booth number 222 in the Design and Simulation Pavilion. The company is presenting the sessions on semiconductor manufacturing and materials engineering, AI-driven chip design. For more information about the Synopsys present and GTC. Okay. Today also thank you for your time and see you next time.